Here's an additional video looking at ionic bonding. So here we're going to look at some different metals, a series of different nonmetals. We're going to use Lewis dot theory to combine them together, make our ionic compounds, and we'll note the Joseph-Proust definite proportion. Magnesium is in the same group as beryllium, so it's going to have the same Lewis dot structure as beryllium. Oxygen, we can see, has 6 dots and 2 boxes, so it's capable of accepting 2 valence electrons. Well, that's perfect because we have 2 valence electrons to give. One goes in here, the other one goes over there. So when we write this down, we know that magnesium has lost its 2 valence electrons. They're gone, it's got 2 positive charges in return, and it's now got an oxygen with 6 dots, original 6 dots, plus the 2 dots that were given to it from magnesium. So oxygen's got its original 6 plus an extra 2, so it's acquired a 2 negative charge. So we've got a +2 and a -2, that sums to 0, which is the case for all ionic compounds. And a chemist would just write MgO in a 1-to-1 Joseph-Proust definite proportion. We'll repeat again for magnesium, this time with nitrogen. So magnesium has 2 valence electrons. Again, because it's in the same group as beryllium, it's an alkaline earth metal. It's a group 2 metal. Nitrogen has 5 dots and 3 boxes. Now here we have 2 dots and 3 boxes, so we've got a 2 and a 3. 2 and 3 factor into 6. So for every dot we need a box for it to go into, so 2 and 3 both factor into 6. So I need to put a coefficient 3 here. So the 3 is going to multiply the 2 dots to give us 6 dots total. I put a coefficient 2 here. The 2 is going to multiply the 3 boxes to give us 6 boxes total. So I'll have 6 dots and 6 boxes. I won't draw the arrows this time because it'll get messy, but we have 6 dots going into 6 boxes. So I've got my 3 magnesium. Each magnesium has a +2 charge because each magnesium has lost 2 dots. So I have 3 multiplied by +2, that's 6 positive charges. But I have 2 nitrogen. Now nitrogen has now filled each of its boxes. Let's put this 2 out the way. So each nitrogen now has been filled. So whereas I've got 3 multiplied by +2, which is 6 positive charges, each nitrogen has gained 3 negative charges. So I've got 2 multiplied by 3 negative, 6 negative charges. So 6 positive and 6 negative sums to 0. Chemists would convert these coefficients into subscripts and just write Mg3N2, which is a 3-to-2 Joseph-Proust definite proportion. And finally, for calcium and phosphorus, calcium is in the same group as magnesium and beryllium, so again it will have 2 valence electrons. Phosphorus is in the same group as nitrogen, so similar to nitrogen, it will have 5 valence electrons and 3 boxes. Okay, so it's going to be very similar here. So like the previous example, we're going to have 3 calciums. That will give me 6 dots. And I'm going to have 2 phosphorus. That will give me 6 boxes. So all the dots go into the boxes. I have 3 calcium. So I've got 6 positive charges. I've got 2 phosphorus. Now the phosphorus acquires a 3 negative charge each, because each phosphorus has now accepted 3 electrons. So each electron contributes to a negative charge. Each accepted electron contributes to a negative charge. So I have 6 positives and 6 negatives. A chemist would just write these coefficients as subscripts. So calcium subscript 3, phosphorus subscript 2, and you can see that's a 3:2 Joseph-Proust definite proportion. And that concludes this video.